Welcome to this week's Journal Club. Today, we're going to be talking about Alzheimer's disease, and Katelyn DeCraine is doing a paper called Multisensory Gamma Stimulation Ameliorates Alzheimer's Associated Pathology and Improves Cognition, which was published in 2019 in the journal Cell, which is not just one of the big four, it is probably the biggest of the four. The most important, and it uses APA format. So if you're ever looking to see, okay, how exactly should I write a paper, they use the classical APA format the way it's supposed to be done. So that's one of the reasons I like them. Okay, Katelyn, it's all you.
So this is multisensory gamma stimulation, ameliorates Alzheimer's associated pathology and improves cognition. So gamma frequency is the thing that they use to improve Alzheimer's disease, and it's a beat in the brain. And basically neurons fire in groups on the same beat. So when your brain requires focused attention or memory, so when more focused attention is required, the beat is called a gamma frequency, and this happens between 30 beats per second and 100 beats per second. So in the brain of someone with Alzheimer's, there's less gamma, or the volume of the gamma frequency is turned down. So the scientists figured out a way to manipulate the gamma frequency with something called genus, and this is gamma entrainment using sensory stimulus. So basically they used a sound at 40 hertz and a light that entrained the gamma in the brain for higher order functioning and tasks in the brain. So this is the abstract, and it shows in the top left, you can see with auditory simulation, and there's a coronal slice of the brain with the auditory cortex and the hippocampus, and that's where they showed the 40 hertz simulation, and basically this led to microglia and vasculature changes, and also improvement in cognition in the mice. And then when they added, in the top right, you can see they added a light source, and this helped for a wider range of parts of the brain. So figure 1 is basically showing that there's more activity. And on the top left, you can see in the auditory cortex, they had different pulses of sound, which are the blue bars on the top. And then under each bar, you can see that there's a greater spike in activity, and more activity picks up after each pulse of sound. And also in figure 1B, you can see between the random simulation and the auditory simulation, there was a greater difference in the time from the pulse. So basically it's showing that the stimulation induces genus robustly, and that there's more activity when the genus is used.
I think it'd be a good time, and maybe am I supposed to do this? Give them an actual sample, right? Yeah. Okay, just give me a second. I thought I had it open, now it's gone. Oh, yeah, I did have it open. It's right here. Yeah, that's a good one. Okay, so let's just take a moment. Okay, in Hangouts, I'm gonna send you all a video that I just Googled 40 hertz pure tone, and this is it. So make sure your microphone is muted, but your speakers are turned up all the way, and go ahead and play that for 20 seconds. Need more time? Okay, that should be enough time. Weird, right? Did hit the raise hand function if you did not hear anything. Everybody heard it. Okay. This is this is the premise of this paper, is that noise somehow helps you. Fair? Is that good, Katelyn? You want to keep going?
Yep.
Okay.
So figure 2 deals with novel objects and how the mice were able to recognize them with the 40 hertz stimulation. So in figure 2b, it says the object recognition index, which is basically when exposed to two objects, one new one and one old one, the mice will spend more time with the new object if they remember the old one. So on the y-axis, it's measuring um, how they spend more time exploring the new object. And the blue bar shows how when the mice were stimulated with 40 hertz sounds and the gamma frequency, they were able to spend more time with the new objects, showing that they had already recognized the old ones. And basically, overall, it's saying that the genus improves memory and spatial memory and improves recognition of objects. And then figure 3 is talking about amyloid load. And amyloid is a protein that forms the plaque in the brains of people with Alzheimer's or the mice with Alzheimer's. So it's saying how it can reduce the amyloid load. So you can see, like in figure 3C, there's the nose stimulus and then the 40 hertz. And you can see there's a significant decrease in the amyloid load. You can see there's less green dots. And they did two types of amyloid loads, the green and the red. And in both you can see there's less. And then figure 6 is talking about both the combined auditory and the visual stimulus with the microglia. And microglia is something that cleans up the amyloid plaques in the brain. So in mice with Alzheimer's, it's
Can I stop you for a moment? Can you go
yeah.
back one? I just figured out something that I think is now important. Katelyn, can you go back one figure?
I think I did go back. One more.
There we go. Yeah, figure 2. Auditory genus can improve recognition and spatial memory in 6-month-old 5X FAD mice. Earlier, we were trying to figure out what that was. It's actually a special strain of mouse that has a knock-in of human APP and presenilin 1 proteins. So these mice develop Alzheimer's-like processing and behavior deficits using human proteins. So I think that's kind of important to keep in mind. These mice are actually designed to get Alzheimer's, essentially, or at least as close as mice can get to Alzheimer's. Okay, go back. I'm sorry.
So microglia they clean up the amyloid plaques in the brain. So on mice with less microglia will have improved cognition. And it's showing how with no stimulation, there's still clustering, but then with auditory and visual stimulation, there's a greater clustering. And you can see that all the way to the right in the top figure. You can see the clustering, the green dots, but then in figure 6E, there's greater clustering on the right. And basically, there's greater microglial responses.
Meaning what?
There's more microglia cleaning up the plaque in the brain. So they have greater cognition. And then figure 7, it's dealing with anti-amyloid beta plaques and how they're significantly decreased in stimulated mice. So again, like the last figure with no stimulation, you see that there's more green dots, and then figure 7B, there's less green dots, which shows the decrease in the amyloid. So basically, there's less buildup of plaque, and the neurons can function better. And this is against, since there's both auditory and visual stimulus, it's across the broad cortical regions. And to sum it up again, the mice with just the auditory stimulus, they saw improvements in the auditory cortex and hippocampus. Well, there was neural activity there, and also microglial and vasculature changes, and an improvement in cognition. Like when they did the novel object recognition test, they saw improvements in that. And then with the sound and the light, there was a reduction of amyloid load across the cortex.
Classically, if you go back to the figure for a moment, I had joked with Katelyn that apparently they become so smart they could play chess because that's a chess piece there. Do you see it? But classically, actually, chess pieces were the novel objects in the test because they were small enough that they'd be interesting and they'd have smells about them depending on who played with them and stuff. So they'd be an interesting stimulus. They have interesting shapes. And so chess pieces actually end up being like one of the main things that people would use. Okay, go ahead.
So the conclusion is, with a combination of auditory and visual stimuli, genus can have impacts beyond the primary sensory areas. So it's seen throughout wider ranges of the brain, which leads to more improved cognition. And multisensory gamma entrainment improves memory in mice. And this can be seen with the mazes that they did with them and the novel object recognition. And a question to ask is, will humans respond to genus the same way as mice? And they're currently doing a clinical trial with, I think it was 15 humans, to see if they'll react the same. And they were playing the auditory sound at 40 hertz.
Okay. Anybody have any questions, comments? Go ahead, Campbell.
So basically, when I'm studying, I should listen to that thing that we listened to.
Katelyn, did I not ask that same question?
Yeah.
What's the answer?
I think that it could.
Well, give your answer first. What was your original answer to that question?
That it only works to improve lost memories and not new memories.
You got me thinking. So I then said to her, yeah, but mice don't have Alzheimer's, so and they're using 3-month-old mice for a lot of these. But I've been thinking about it with this, what was it called? 5X fad. Yeah. With this 5X fad mouse strain, they really were working on animals that did express the same proteins as Alzheimer's. So you might be right, Katelyn. It may not actually improve us normal people, only people who actually are starting to have increases. But I can't see why. I can't see how it could hurt you to do that, except maybe going nuts. Like maybe it might drive somebody, if somebody puts a message into some subliminal message into the 40 hertz, whatever, right? And all of a sudden you're out like eating people's faces, bath salts style. I said the same thing to her. Like, should I be, you guys are all going on spring break and I'm going to end up sitting at my desk and working. It's going to be really hard to focus. Should I be playing 40 hertz noise? If you go on YouTube right now and you just type in 40 hertz by itself, just 40 hertz, see what comes up. It's all this like study stuff, like to study. It's like music almost. Other questions? There's a couple things in this study, if nobody's going to ask a question, there's a couple things in this study that I want to point out because I thought they were cool. Things that are so cool that if you learn about them, they make you want to do science. Okay. If you look at, let's see. Yeah. Close. If you look at the paper, and you look at the names of the paper. So first of all, Katelyn heard about this paper from Radiolab, right? Katelyn, can you send us all the link to the Radiolab episode? I love Radiolab. The guy who created Radiolab, whose name is Abumrad. What's his first name? He has an interesting first. Jazz. Jad, you're right. Jad Abumrad. His dad is a doctor at Vanderbilt Medical Center, but he started this thing and he actually won the Genius Award. What is it called? What it's named after something, MacArthur or something like that. It's a MacArthur grant or something. I'm forgetting, but he won this award as like which are referred to as the Genius Awards. There's only a few given every year for his work on Radiolab, and it's probably my favorite radio show ever. So that's available there. If you look at the paper, the person who was in the Radiolab episode was Dr. Tsai. She's a genius, and then Kwang Hoon Chung actually trained me on how to do something called clarity. Clarity is the thing that I think is so cool that you might. So he actually came up with the idea of clarity while in the lab of Carl Diceroth. Does that name ring a bell? Carl Diceroth. It should. One of you presented some of his work. You guys know what optogenetics is? Do you remember optogenetics? He's probably going to win the Nobel Prize for inventing optogenetics. You shine a light on a neuron and all of a sudden it fires. Jordan, I know we've talked about him actually when you're doing your capstone. He had Chung in his lab. They worked together. They come up with this idea where you can take a piece of tissue, let's say a brain, and if you look at a brain, you take the brain out fresh, right? And you look at that brain is kind of this very pale pink, kind of between a tan and a pink. And so you can't see inside that brain. However, if you take that and you perfuse in using electrolysis, you perfuse in a type of hydrogel, a gel that actually forms inside of the cell. And then you wash out all of the fat using high concentrations of sodium dodecosulfates, SDS soap, right? High concentrations of soap, and you wash out all of the fats that are in the brain becomes completely clear, completely translucent. But it has all of the cells and all of the proteins still in it. So in this study, the figures that Katelyn didn't really go into, figure 3 and 4, these were done on these brains so that you could see where the cells were in the brain and how they were associated with other brains. My plan in learning how to do it was I was going to do clarity to see how the circadian rhythm worked. So I was going to take probably a couple hundred brains, clear them, and look at them at different times during the day to show which cells were on or whatever. And I never got around to it. Something worth considering in a high school setting because it's actually not too hard to do. But they did that too, and I think that's one of the ways this was a novel study. So, Katelyn, does this belong in Cell, the best journal in the world?
Yeah.
A resounding yes from Katelyn. Yes, it belongs in Cell. This is pretty remarkable because it's like a drug-free treatment for Alzheimer's. And you said it's in clinical trials on humans?
Yeah.
And did you say 15?
Yeah.
That's a really small sample.
That's what it said on the Radio Lab podcast.
Are the 15 people who are already showing symptoms?
It was early on Alzheimer's.
Early onset Alzheimer's?
Yeah.
Oh. So early onset Alzheimer's is a little different than regular Alzheimer's. Early onset usually happens in your 40s or 50s, but it's a really severe form of it that you don't. So the average lifespan of somebody who gets diagnosed with Alzheimer's is something like 5 to 7 years at the most. Now, if some of you are going, wait a minute, my grandmother had it for like 10 years. The life expectancy has increased significantly over the last few years. My grandmother had it for 13 years. But one of the dirty secrets, just like with concussions that we've talked about in some of the other classes, where like concussions, what's the definition of a concussion? It's like brain boo-boo. We don't really know what it is. Alzheimer's can only be diagnosed with you can only be sure that somebody has Alzheimer's doing a post-mortem processing of the brain. You have to remove the brain, slice it up, and then the diagnosis comes.
You can't use symptoms and shit?
Nope, because the symptoms could be really of any type of dementia. The best we could do is say, oh, yeah, they have dementia. Now, there are some tests in development. I know a few years ago there was a salivary test for some protein that was in development, and I don't know how far it got because I don't really study Alzheimer's. But if you have something like Parkinson's, Lewy body disorder, early onset Alzheimer's, mild cognitive impairment, hydrocephalus. There's a whole bunch of different disorders that all come out with the same type of symptoms, symptomology. So it's really hard. Now, our MR scans have gotten very, very fine. So we're starting to be able to do it with MRI. MR, really, not MRI, because people in the know the people in the know. No, the people that know call it an MR. Okay. Any questions? Anyway, goodbye, everyone. See you later. Thank you, Katelyn. Oh, good job, Kate. Yay. All right. See you later, everyone.